Okay, so today we're going to cover Chapter 9, Section 2. Today we're going to be learning about special right triangles. Now, once I teach you about special right triangles, you're going to use this knowledge for the rest of the school year, and you'll also do this in Algebra 2 next year when you start talking about the unit circle, and you'll be creating triangles within that circle. Now, before I go ahead and get into the theorems for the special right triangles, let me review rationalizing the denominator and also adding and subtracting with radicals and multiplying. This should have been something you covered in your Algebra 1 course, but again, I'll review it. So, on the homework that was due this morning, you had some questions at the end to review your skills of rationalizing the denominator. So for example, let's say I give you a fraction and I have 18 over the square root of 3. What we're going to be using a lot in this lesson is the square root of 3 and the square root of 2. Now, in math laws or math rules, you can never ever leave a square root in the bottom of a fraction. So in order to get rid of that square root in the denominator, I need to make it a perfect square. And to do that, usually the easiest way to make it a perfect square is multiply it by itself. However, when we do this, whatever I do to the denominator, I also have to do to the numerator. So I'm going to also multiply the numerator by the square root of 3. And essentially what I've done here, this is just equivalent to 1. So really all I'm doing is multiplying that fraction by 1, but it's going to change how it looks. So what I'll do is I'm going to go ahead and multiply straight across 18 times the square root of 3. Whenever you multiply radicals, all you're going to do is multiply outside numbers with outside, what's underneath the square root with what's underneath. This one doesn't have anything that's different, so I just write the two things side by side. For the denominator, just like before when we were breaking down the radicals, I've got a pair of square root 3's here. I don't have to multiply it and get the square root of 9 and then square root it and get 3. As soon as you make a pair, it comes out of the square root. Now, just like when we're multiplying, you got to multiply numbers outside with outside, inside with inside. Now I can do the same thing when I simplify. I'm going to simplify the numbers that are outside. I can do 18 divided by 3 and get 6 and then put the square root. Let me just do another one. Let's say I have 7 over the square root of 2. Again, I need to make that denominator a perfect square. Easiest way to do it is multiply it by itself. And then now multiply the 7 times the square root of 2. Nothing to multiply because the 7 is out, 2 is underneath. So just leave it side by side. I got a pair of square root 2's and I just put 2. So once you make the pair, it comes out of the radical. Nothing simplifies here. Let me do one more where it'll simplify. 8 over the square root of 2. Again, multiply top and bottom by that square root of 2. And then I'll multiply straight across. 8 times the square root of 2. Pair of 2's comes out. And again, this one will simplify. I can divide 8 by 2, and it simplifies to 4 square root 2. Now, one other thing we're going to be asked to do in the homework and in the notes is to find the perimeter of some figures. And the side lengths on these figures are going to be radicals. So whenever you're asked to add something that's got a square root, so for example, let's say I wanted to add 4 square root 3 plus 4 square root 3. Whenever you add radicals, the number under the square root has to be the same. Sort of think of it like this. 4x plus 4x. Think of the square root of 3 as like an x, and all we're doing is adding the numbers outside. This would give you 8x, and then this one gives you 8 square root 3. So whenever you're adding radicals, they have to have the same number underneath. If this had, let's say it was 2 square root 5 in front here, I can't add 5 plus 3. I would just leave them apart. So treat them like variables if it were an x and a y. So we're going to be adding some radicals when we're finding the perimeter. So the first theorem is called 45-45-90 triangle theorem. Again, don't memorize the number. It's just the fourth theorem in the lesson, so don't memorize that number. What this states is that in a 45-45-90 triangle, the hypotenuse is going to be the square root of 2 times the long as each leg. So, for example, if you notice, this is actually an isosceles right triangle. Because if you notice, A and A are the same, and then the hypotenuse, the side across from the 90, is going to be A times the square root of 2. So this is the hypotenuse. Okay, so what's going to be given to you is this only works for right angles or right triangles. You'll be given one other angle besides the 90 degrees, and then you're going to be given one of the side lengths. And then from that, you'll be able to find all of the other pieces. So the two legs, these are each legs. This is a leg, and this is a leg. And again, the side across from the right angle is the hypotenuse, and it's always the longest side. So let me go ahead and redraw this, and I'm going to add some numbers to show you how it works. So let's say I draw another little right triangle here, and I told you one of the angles is 45. Now, in order to get the other angle, you could use your triangle sum and add up 90 plus 45 and then subtract from 180. Or also remember the two acute angles of a right triangle are complementary. So you could do 90 minus 45 and realize that this one is also 45. We learned when we covered isosceles triangles that if you have two congruent angles, then also the two sides across from those angles are also congruent. So since this is a 45-45-90 right triangle, I'm going to label my legs as A. You don't have to use the variable A. That's generally what I use. In the homework, they may have an X there. But just know that those are going to have the same letter because they're congruent. And then the hypotenuse is going to be whatever A is times the square root of 2. So let's say I told you A equals 8. So that leg is 8. So this leg would also be 8. And then the hypotenuse, I just take out A, put an 8 there, and then put the square root of 2. We are going to cover one other special right triangle. It'll be the 30-60-90. Now, because we're going to be dealing with the square root of 2 and the square root of 3, one thing that helps me to remember which triangle gets the square root of 2 and which one gets the square root of 3, I know that this one has two equal angles or two equal sides, so this one gets the square root of 2. The next one we're going to cover is 30-60-90. It'll be 3 different angles, 3 different side lengths, so it's going to get the square root of 3. Whatever trick's going to help you to remember, but you need to memorize the relationship of the sides. So let's go ahead and take a look at the next one, or let's do an example of this first, then we'll look at the next theorem. So here we go. They want us to find the value of x. Notice they didn't label it as A. You can use whatever letter you want. So these are the two congruent sides. So because I have two congruent sides, this also tells me that I have two congruent angles here. And when it's a right triangle, those two angles are both going to be 45. So if this is x, and if you want to use the letters I used before, this x is really our A and our A, and then our hypotenuse is supposed to be A times the square root of 2. So what I'm going to be doing is I am going to solve A square root 2 equals 6. This is where rationalizing is going to come in. So in order to solve for a, I have to divide both sides by the square root of 2. A is equal to 6 divided by the square root of 2. I can't leave that radical in the bottom. I have to rationalize, multiply the top and the bottom by the square root of 2 to make that denominator a perfect square. And now it becomes 6 square root 2 over 2, and then I can simplify it. And this will give me 3 square root 2. Now remember, this was a, but it's also our x. So this side is 3 square root 2, and this side is 3 square root 2. What they had given us was the hypotenuse, and we were trying to find the 2 legs. So let me just redraw another 45, 45. And let's say this time I gave you the leg, or the A, to be 3 square root 2. So what you have to recognize is that these two are the same. So this will also be 3 square root 2. But this guy over here, the hypotenuse, this is supposed to be A times the square root of 2. But remember, your A value is 3 square root 2. So that's what I'm going to put in right here. So 3 square root 2. And then now I need to times it by square root 2. I got a pair of square root 2's. This comes out. And then times it by the 3. And that's how you get a whole number for that hypotenuse when your leg has the square root of 2. Now, one other thing to remember is your figures are never drawn to scale, so you can't go by how big it looks. So just always remember that. Just go by whatever numbers are on there and then apply the theorems. So let's try the next theorem, which is also our next special right triangle. Again, don't memorize the number. This is called the 30, 60, 90 right triangle. And what this one states is that the triangle in the 30, 60, 90 triangle, the hypotenuse is going to be twice as long as the shorter leg, and the longer leg will be square root of 3 times as long as the shorter leg. Now, if you remember back to your triangle inequality chapter, remember, the smaller the angle, then the side across from it is going to be the shortest side, or the biggest angle will be always across from the biggest side. So in this particular picture, my smallest angle is the 30. So this side across from the 30, this is going to be the shorter leg. This is going to be the smallest side of my triangle. And then the 60, this is going to be the longer leg. But remember, the hypotenuse is always the biggest side. Because it's across from the biggest angle. It's across from the 90-degree angle. So let's try it with some numbers. So if I draw my 30, 60, 90. Now, the 30 isn't going to always necessarily be up at the top. It may be down here. And then the 60 up here. And then the right angle. What you need to remember is the side across from the 30. That's your A. And again, notice I did not draw this to scale, because obviously that side looks bigger, so never go by how it's pictured. And then the side across from the 60 is going to be A times the square root of 3. and then the hypotenuse is going to be 2 times A. So let's say I gave you what A equals. Let's say I tell you this side is 7. So then to find the hypotenuse, that's the easiest one. 2 times 7, and the hypotenuse will be 14. And then the side across from the 60, 7 with square root 3 behind it. Okay, so here it wants us to find the value of x. So notice they only gave me one side and a 90-degree angle and then the 60. So you can use your triangle sum and you can go ahead and add 90 plus 60 and subtract that from 180 to find out that this missing angle up here is going to be 30. You're going to get to recognize that when it's a right triangle and if they give you one of the angles is 60, you're going to know it's the other one's going to be 30. Or the same thing with the 45, 45. All right, so now let's go ahead and label these. So remember, the smallest side, or the one across from the smallest angle, is going to be our A. The side across from the 60, that's where it's going to be A times the square root of 3. And then the hypotenuse, the side across from the right angle, will be 2 times A. So I already have A. A is 5. So over here, if I do 2 times 5, I'm going to get y is equal to 10. Up here, just put the 5 in front of the square root of 3. And we're done. Let me draw another right triangle. $60 and $30. And let's say this time I give you 18 here. And I ask you to find the other two sides. So remember, this side across from 30, that's where A is. The side across from 60 is A square root 3. And remember, this 18 is equal to 2A. So I'm going to solve the equation. 2A equals 18. Divide by 2. And A equals 9. So the shorter leg is always half of the hypotenuse. And now the longer leg, now that I found A, I just put it in front of the square root of 3. Let's do another one before we move on. Let me draw it this way. It doesn't matter, you just have to look at the numbers. So let's say this is 30. The right angle, and 60. Let's say I told you that A equals 2 times the square root of 3. So remember over here, this is A square root 3, and this one's supposed to be 2A. So what I need to do is take what A is, this 2 square root 3, and I need to plug it in to the A here. So I'm going to be doing 2 square root 3, then put the square root 3, that's part of the thing you're memorizing, pair of square root 3's, so a 3 comes out, so 2 times 3, and this side is 6. For the hypotenuse, 2 times 2 square root 3, multiply outside with outside, and the hypotenuse is 4 square root 3. Here it says the diagonal of a square has a length of 6. What is the perimeter of the square? So let me go ahead and draw a picture of a square. I'm going to label my diagonal. Now, for the diagonal, it doesn't matter if I draw it this way or this way. Just remember it needs to go from 2 non-consecutive vertices. So remember the sides of a square, they're all going to be the same. So on this one, I could say that these are all A's. Another thing you should remember from a square is the corners are all right angles. You should also remember that one of the properties of a rhombus is the diagonals bisect opposite angles. So soon as I see this, I know that this angle was bisected. So this 90 divided by 2 is 45 and 45. You could also recognize it's an isosceles triangle and that those two angles need to be congruent. So now what I'm going to focus on is just this triangle here. I'm not going to do the whole square. I'm just going to focus on one of the triangles. And it's one of the special ones that I just covered. So let me just pull that one out. And you could have done the bottom one, it doesn't matter. So this was A, and this is going to be the diagonal is a square root 2. And the diagonal, they told us, was 6. So what I need to do is I'm going to take a square root 2, and I'm setting it equal to 6. So a square root 2 equals 6. Divide by the square root of 2. A is equal to 6 divided by the square root of 2. Rationalize it. Multiply top and bottom by the square root of 2. Then this becomes 6 times the square root of 2 over 2, which simplifies to 3 square root 2. So that is each of the legs, which is actually the side of my square. So each one of these sides is going to be 3 square root 2. So now that I have the length of the side of the square, I can now find the perimeter. So remember, for perimeter, we can either do 3 square root 2 plus 3 square root 2 plus 3 square root 2 plus 3 square root 2, and there's 4 of them. Remember, when you add radicals, we're just adding the numbers outside. So this will give me 12 square root 2. And there's no units in the picture, so I would just say that it's 12 square root 2 units. The other way you could do it is if you recognize that it's a square and just do 4. There's 4 sides, and do 4 times the square root, 3 times the square root of 2, and you get the same answer either way. So either add them all separately, or since it's a square, all 4 sides have the length of 3 square root 2, so just times it by 4. Now, also in the homework, they're going to ask you to calculate area. So let me just add to this question. Let's also find the area of the square. So remember, area of a square is either side to the second power, or you could also do length times width or base times height. The only difference is the base and the height, or the length and the width, are the same number. So really it's just going to be 3 square root 2 times 3 square root 2. Multiply the two outside numbers. 3 times 3 is 9. You got a pair of 2's, square root 2's, so the 2 comes out. So the area here is going to be 18 square units. So be able to do both perimeter and area. Whenever they're asking you to do a word problem from this lesson with a square, and if they draw in the diagonal, it turns into the 45, 45, 90. The next one will be an equilateral triangle. And again, if a picture is not given, draw yourself a picture. Okay, so for example 4, it says an equilateral triangle, so let's draw that, has an altitude length of 5. Now, remember, an equilateral triangle is also equiangular. So in addition to these sides being equal, we also learned a corollary that stated that all equilateral triangles are also equiangular. So now let me draw in the altitude. And it has a length of 5. Now remember, when it's an equilateral triangle or an isosceles triangle, That altitude is also a median, and it's also a perpendicular bisector. Now, I'm only going to focus on half of the triangle, so I'm going to just pull this guy out and work with this half to get the length of the side, which is my hypotenuse. So if I pull this out, and this is already 60, and this was 90, you can already see that this angle up here is 30 by using your triangle sum. You can also see that that angle was bisected. So now, only thing we have is 5. And notice the 5 is opposite the 60-degree angle. So this 5 is equal to a square root 3. This is a, this one will be 2a. So I need to solve for a. So I take my a times the square root of 3, set it equal to 5, divide both sides by the square root of 3, and I get a is equal to 5 over the square root of 3. Can't leave that radical in the bottom. Rationalize it. So a is 5 times the square root of 3 over 3. So that's this side down here. The hypotenuse, which is actually going to be the side of my triangle, is going to be 2 times that. So I'm going to take 2 and times it by 5 square root 3 over 3. And that's going to give me 10 square root 3 over 3 is going to be the hypotenuse, which, remember, is also the side of the triangle of the equilateral. So each one of the sides of the original equilateral triangle are going to be 10 times the square root of 3 over 3. So now let's find the perimeter. So perimeter, you can either do 10 square root 3 over 3 plus 10 square root 3 over 3. Remember, whenever you add fractions, you need a common denominator. It already has the common denominator. All of these are like radicals, so all we're doing is adding up the tens, and I get 30 square root 3 over 3. I can simplify the 30 and the 3, so the final perimeter is 10 times the square root of 3 units. I'm going to do the same thing and find the area of that equilateral triangle. So for area of a triangle, remember the formula is either 1/2 base times height or base times height divide by 2. The choice is yours. So the base is the 10 times the square root of 3 over 3. And my height was that altitude, which was 5. So let's plug those numbers into the formula. So 1/2 base 10 times the square root of 3 over 3 times the altitude, and I'm going to make it 5 over 1. So now I could multiply straight across, or I could simplify before I multiply. I'm going to simplify the 2 and the 10 and change that 10 to a 5. And then now I'll just multiply. 5 times 5, the 2 outside numbers, radical 3 over 3. And this would be units squared, or you could say square units. So in the homework, you are calculating area and perimeter. And again, if a picture is not provided, give yourself a visual. It makes it a lot easier.